Alright, this is the last section for 11.3. This is part 3. We're going to be focusing today on non-parallelograms, which we already took notes on during class. So non-parallelograms, I have two. I have kites and I have trapezoids. There's 3 different properties for each of them, and we're going to see them in the examples that I'm about to set up. So in example 11, the name of that shape is a trapezoid. So I'm going to be looking at properties for trapezoids. But first, I'm going to label my triangle with the information, oh, not my triangle, my trapezoid with the information that's given to me. So they're giving the measurement of angle DAB, and that is this angle, DAB. So that angle right there is 21x minus 48. And then they gave me a second angle, which is CBA. So CBA is that angle right there. That one's 6x plus 60. Okay, so for this one, I'm looking at angles. So I'm going to look for information about angles in a trapezoid. So if you look at your notes, here I have base angles are congruent. The bases of my trapezoid are the top part of my trapezoid and then the bottom part of my trapezoid. And so those are bases, and the base angles are those 2 corners on each of those bases. So here I have the base angles for the top side, for the top base, and so those are congruent. So that's the property that I'm going to write down. Base angles are congruent. And so congruent means equal. So to solve this problem, you have to put those 2 equations equal to each other. 21x minus 48 equals 6x plus 60. You would solve for x and then plug it back in for DAB. Again, I'm just setting them up. I'm not solving any of these problems. Okay. Example 12 I will solve because it's a little bit different than the other ones. But first, let's go ahead and label our information. So I still have a trapezoid. And I have measurement of angle BAD. And then they give me the measurement of angle ADC. ADC. That one. And so I'm still looking at information about angles. So I'm going to look at my notes for trapezoids. Base angles are congruent, but in my example, the 2 angles that are given to me are not base angles. So those are not congruent. They're not equal to each other. So I only have 2 other properties that I can work with. I have the diagonals are congruent, but that doesn't help me in any way with the angles. And then I have bases are parallel. This is going to help me if we remember from last semester something that we learned about parallel lines. So last semester we worked with parallel lines and transversal. So if my top and bottom sides, the bases of my trapezoid, are parallel, then this line right here would be like the transversal. It's just a line that's cutting through those 2 lines. And so if I extend my bases, the angles that are given to me would be same side because they're both on that right side of the line, interior because they're both between the bases. So same side interior angles are supplementary, which means they add up to 180. So for this one, same thing. If I extend my lines, I have same side interior angles, and so that means they add up to 180. So for the property that I'm going to use, I'm going to write that the bases are parallel. That's what helped me with this problem. Bases are parallel. And so that would mean that those two angles are alternate interior. I mean, same side interior, I'm sorry. Same side interior. And so that means that they're supplementary. They add up to 180. So for this problem, I have to add both of them. 5x minus 7 plus this one, 4x minus 2. And then put that equal to 180. Okay, so to solve this, you would add your x's first. 5x's and 4x's, that's 9x's. And then negative 7 plus negative 2, that's negative 9, equal 180. And then from there, I'm just going to get x value by itself. So I'm going to add 9 to both sides to get rid of the constant. And so now I'm left with 9x equals 189. And then I have to divide by 9. And so 189 divided by 9 gives me 21. So my x value here is 21. And my measurement of ABC, I'm just going to plug in my 21. So for the measurement of angle A, B, C, they're asking me about this one, A, B, C, it's this one. Even though they don't give me an expression, I still have to remember, well, base angles are equal. So if I plug it into this top blue angle, then that should be the same as angle ABC. So I'm going to plug it into the blue one. Blue one is 5x minus 7. And so when I do that, I get 98 degrees. So ABC is 98 degrees. So this one was just a little tricky just because you had to think about previous things that we've learned in geometry. Alright, so two more, but the last two examples that we are going to look at are kites. And so kites, I have 3 different rows. So here are my row for kites. I'm going to be looking at this ones now. So example 13 is kite. And I'm going to label my information in my picture. I have angle ADC. It's this one right here. And I have angle ABC. Just this one right here. And so again, information is about angles. So I'm going to look at my picture, my notes. This talks about angles right here. One pair of congruent angles, and I can see from the notes that those are the 2 angles on the sides, which are those 2. So those 2 are congruent. So one pair of congruent angles. So to solve this, I'm going to put them equal to each other. And then the last one I am going to solve, because again this one's a little bit different. So let's look at this one. I have a kite, so it's still a kite, and I'm going to label my information. So the information they're giving me is BC equals 5. So from point B to to point C, that side right there, that is 5. And then they're giving me XB. So XB is this line right here. That one measures 4. And they're wanting me to find XC. So XC is this line right here. This is what they want me to find. Alright, so for this ones, I'm going to look at my notes. Information is about diagonals. So diagonals are perpendicular, which means they intersect at 90-degree angles. So those are my diagonals inside my kite. They intersect at 90-degree angles. So that means that this angle that was created right here with my diagonals, that's 90 degrees. And so to be able to find XC, again, I have to remember something that I used last semester, which is a squared plus b squared equals c squared, Pythagorean theorem. So you remember C is always a hypotenuse, so this is going to be my C value. And then A and B doesn't matter which one's A and B. So now I'm going to plug it in to my formula. So for this one, I'm using A squared plus B squared equals C squared. And remember, you only use this theorem if you have a right triangle. That's why I'm using this. So A is 4. So I have 4 squared. B is what I'm trying to solve for, so I'm going to call that X. And then C is the 5. So I just plugged into my formula. I'm going to evaluate each term. 4 squared is 16. 5 squared is 25. And so now to get X by itself, I have to get rid of the 16. X squared equals 9. And so to get rid of that exponent, the square, opposite of the square is the square root. So it cancels out. I'm going to do it on both sides. And so the square root of 9 is 3. So then XC equals 3. And the property that I used for this was that the diagonals are perpendicular. So remember, perpendicular means they intersect at 90-degree angles. Alright, for all the videos, part 1, part 2, and part 3 for this section, I only worked out a few of the examples, but if you want to see all the problems entirely worked out, you can always click on the 11.3 notes, the PDF, and it'll have them all worked out for you.